Desired state configuration, writing a DSC resource. Now, in this nugget, we're going to expand DSC's capabilities. In the previous nugget, you learned that you can write a configuration script, and in that configuration script, you reference resources. You tell the resource how you want a computer configured, and the resource takes care of actually making it happen. We've used a couple of examples already, but in this nugget, we're going to write a custom resource so that a configuration script could give it some configuration parameters, and then it will actually do the task of checking those, implementing them, and making sure they stay in place. Now, this isn't going to be a terribly complicated nugget because resources in DSC are basically just a special kind of PowerShell module, and that's something that you've written several times in previous nuggets, so hopefully it'll look a little bit familiar. I'm going to start by showing you where PowerShell keeps its native resources, the ones that it comes with. So that's kind of a hint that we're going to be working entirely on PowerShell version 4 in this entire nugget. I'm going to be actually using my Windows 8.1 computer since I have PowerShell version 4 installed there. Then I'm going to show you how to write a custom resource. Now I'm going to do that by actually going to a publicly available GitHub repository at PowerShell.org where several community members have donated several community modules. So we're going to talk about naming conventions, and I'm going to walk through a custom resource that's up there. And one of the reasons I'm doing that is because it's publicly available, so you can get to it, use that resource exactly as it is, or any of the other ones that are there, or use it as a starting point for building your own. Now, I want to start by showing you where PowerShell keeps its native, its built-in DSC resources. This isn't necessarily where you want to put yours, but it is certainly an option. There's a naming convention that goes with these things too that I want to call to your attention while we're in here. So I'm going to change to PowerShell's installation folder, $PS home. DSC resources are, as I mentioned in the introduction, are really just a special kind of PowerShell module. PowerShell keeps all of its modules in a special set of folders. You can actually find that path or all of the legal paths by looking at the PS module path environment variable. You can add to this. So you can set up your own modules folder somewhere. Now, for the purposes of desired state configuration, resources really need to live locally on each computer. That's because the local configuration manager, or LCM, that's the bit that's actually doing DSC, that things runs as the system account. That means it does not have easy access to network resources. If you've set up a pull server, part of what you can do on a pull server is store your modules, your resources, so that whenever a computer downloads its configuration and checks it, it can see what resources it's missing, and it can find them on the pull server and download them via HTTP or HTTPS. That doesn't require any particular permissions as far as the network, not like downloading from a network share would. So for the purposes of DSC, you should plan to have a pull server in place. That's probably the ideal architecture. Keep all of your DSC module source there so that your configured nodes can then download from there. But we're going to look at where the built-in ones are. So we'll start by going to the modules folder and then go to PS desired state configuration. There's a bunch of stuff in here, but the good stuff is under DSC resources. And these are all the built-in resources. In fact, in the previous nugget, I listed these. You've got the archive resource that can do zip files. That lets you modify environment variables, local groups, local users, logging, installer packages, processes, dealing with the registry, scripts, running just a plain old script, installing Windows roles and features, and services. You'll notice that these resource names are all preceded by MSFT_. That's a naming convention Microsoft has come up with to make sure their resource names are set aside. You do not want to create your own and have that MSFT_. Now, also in the previous nugget, I showed you the wave 1 of DSC resources that Microsoft has released, and those resource names all started with X, meaning they were experimental. Microsoft recommends that any DSC resources created by and released to the general community start with a C for community. The naming convention is just designed to make sure your resource name stays unique. What you don't want to do is come up with a custom resource called Exchange Server, because it's entirely possible the Exchange team is going to come up with one like that, and there's going to be a conflict eventually. So my recommendation is you might come up with a prefix for your resource names that somehow reflects your organization name. If you work for Contoso, maybe you put a CTSO on the front of your resource names, just to make sure they stay unique. So we're not going to mess with any of the built-in resources. Those are considered part of the operating system, and you wouldn't modify them any more than you would modify any other core operating system file. What I do want to do, though, is take you up to the internet so we can see where some of these community resources are located, and we can walk through a couple of them. So to do that, I'm going to go to github.com/PowerShell.org. Now this is all free stuff. You don't need to sign in or anything. You can get to all the PowerShell.org's free ebooks right there, actually. And we are going to go through to the DSC tree. There's a bunch of information in here, and we are going to dive into resources. And I'm going to take a particular look at the C computer management. This is a community module. It's been released to the community, so it's got the C on the front of it. This resource actually duplicates some of the functionality that was released in the Microsoft experimental resource, but these guys created this well before Microsoft did, and it's a really well-architected resource. It's also, and this is the reason we're going to look at it, it's also relatively simple in terms of what it does, so it's kind of easy to digest what it does. Now, before we start digging through those, I'm assuming that your ultimate task here is to eventually write your own DSC resources. So I want to point you to something else. Let's just do a quick search for DSC Resource Kit. One of your first kits, or first hits, kit hit, is going to be the DSC Resource Kit. And they've got a whole bunch of additional resources in here. Now, these are ones that I didn't talk about in the last one. AD domains, domain controller, AD user. But there's a particular one I'm looking for. We might have to go back to wave 1. Yeah. I think we're going to have to go back to wave 1. Hang on a second. Let me go dig up the URL for that. This is the one I was after. Resource Designer Tool. So if you search for that, this is actually a downloadable module that Microsoft offers that helps you create the structure for a new DSC resource. And this article, which is from the official Windows PowerShell team blog, walks you through using that. Now, you don't have to use that. You can absolutely hand code one of these things, and I don't find it that difficult to do so. But if you get into a really, really complicated one, then perhaps this will be useful. But I wanted to point out where this was. So let's go back over here, and we're going to walk through one. I'm going to dive into the actual resource bits here. This resource consists of two components, a script module, which is in the PSM1 file. So I'm going to open that up in a separate tab, and a schema moth. So let's look at the schema moth first. This is a really, and this is something that the designer tool will produce for you, but this is a really simple text file. And it simply describes, first of all, the name of the resource, pshorg_c computer, that's the name of the resource. And it indicates that this derives from the base resource that Microsoft created. Now the friendly name, this is what you would reference in an actual configuration file. So in a config file that you wanted to use this resource, you would have your top-level configuration section, then you would have a node section, and then you might have a section called C computer. So let's actually take a minute. I'm going to open up the ISE. And you might start with something like this. Configuration, my config, name it whatever you want. Node, number 2, or whatever you're going to do nodes. Remember the previous nugget we talked about writing configuration scripts, so more rules there. But C computer. In here, in this C computer section, you provide all of the parameters that that resource needs, and the schema actually lists them. So it's going to be name equals something, right? It's going to be domain name equals something, and it looks like the last one looks like credential. Now, just looking at this, I don't think it makes a ton of sense to include both a domain name and a workgroup name, but it does accept all four of these. In a minute, we're going to look at the code and see if it'll actually do something different, what will happen. So this is how you use this. You reference the friendly name inside of a node block, then you provide each of the input parameters, the attributes that this resource requires, and the schema simply defines what those are. This has got to be unique, that's why it's a key. This is writable, this is writable, and this is writable, meaning you can provide values for those things. And you can see that this is a string, this is a string, that's a string, and that's a string. Now let's take a look at the actual code. This is just a script module. It's just PowerShell. It's saved as a PSM1 file, just like the other script modules we've created. I'm going to scroll all the way to the bottom because I want to point out that when this module gets loaded, when PowerShell's local configuration manager loads this module, the only functions from this module that it will see are those functions whose names include -target resource. That's important because your modules can absolutely include helper functions, things that you just want to use internally, but that you don't want to expose to the DSC system. Here's a perfect example of one. This function is called validate domain workgroup. Well, the function name does not include -target resource. Therefore, that function will not be exported. It will not be made visible to anything that uses this script module. It will still be callable by other code that's inside this same module. So the basic structure for a DSC resource is that it must implement three functions: get target resource, set target resource, and test target resource. Get target resource retrieves the current configuration for the things that this resource is concerned with. Test target resource lets you specify a configuration, and test target resource will indicate a true or a false if the current configuration matches what you specified. Finally, set target resource allows you to specify a configuration, and it will make sure that that configuration is implemented. Each of these functions has the same parameter block. It's defining parameters for name, which is mandatory, domain name, credential, and workgroup name. So that's set target resource. Let's look at get. Name, domain name, credential, and workgroup name. Now let's go down and look at test. Name, credential, domain name, and workgroup name. Those are the things that were defined in this schema file. So whatever you define in here, you have to implement here, and it has to be an identical parameter block for both the test, get, and set target resource functions. So these all start out as essentially a template of the same things. Let's start by walking through the get target resource. The first thing this is doing is retrieving a new SIM instance of Microsoft's credential object, and it's providing the username that you passed into the credential and the password that you passed into the credential. So I can kind of scroll over a little bit to see the rest of those. So that's the incoming credential. Oops, did not mean to right click. The next thing it's going to do is grab the environment variable for computer name. It's going to query WMI for the Win32 computer system object and grab the domain property. It's going to grab whatever credential you provided and essentially spit it back out again. And then again query Win32 computer system and grab the workgroup property. These are being assembled into a hash table that has four properties: name, domain name, credential, and workgroup name. Those are the same parameters that you provide as input to this. And it simply returns those. So running get target resource, you do need to provide a computer name because it's mandatory, but that information is not actually used in the code. You do need to provide a credential that will be used. This is going to go get the current computer name, the current domain name, the current workgroup name, and return those to you. So it's getting the current configuration for the items that this resource cares about, which are these four things. Now let's go down to test target resource. We're going to come back to set because it's the most complicated. The first thing it's going to do is check and see if the computer name you passed in matches the current computer name. So this is going to result in true or false, and that will get saved in the test result variable. Next, it's going to call the validate domain workgroup function. I showed you that right down here. This is one of the ones that's private to this module. It's not going to be seen anywhere else. This is taking a domain name and a workgroup name, and it's really just testing to see if they both contain a value. If they both contain a value, this is going to throw an error that says you can provide a domain name or a workgroup name, but not both. Please modify your configuration script over here so that you're providing just a domain name or just a workgroup name. So in fact, it will accept both, but it will throw an error if you provide both a domain name and a workgroup name, which makes sense because you can't belong to both a domain name and to a workgroup. So if this is not the case, if you did not provide a domain name and a workgroup name, then you will not get an error, and so you will pass line 192 and you'll come down to here. We're going to retrieve the computer system object from the local WMI repository. Keep in mind, DSC resources all run locally on the computer that is being configured. Now, if you provided a domain name, but you did not provide a credential, we throw an error, because if you want to provide a domain name, then you need to give a domain credential. If you provided a domain name and did provide a credential, we're going to set test result equal to test result Boolean and we're going to check and see if the domain name you provided equals the current domain name. Now this is a neat little trick here. Think about what happened just up here. Let's say the computer name was correct. That means test result will now be true. So let's do a little Boolean drawing. If the name equals the current computer name, then test result will now contain true. That means right here, this is true. This is also true. Actually, we're setting that. So this test result is true. We're going to test to see if the domain name equals the current domain name. If it doesn't, that's false. True and false is false. That means this is now going to contain false. So you see, that's how we're conducting several different tests and sort of accumulating the best case. At the end of the day, down here, test result is being returned as the result of this function. Test result will only be true if every single one of the configuration parameters you specified matches. So when we call test target resource, it's actually testing 2 of 3 possible things. It's always going to test the name. It will test the domain name if you provide one, or if you provided a workgroup name, it will check that. At the end, this gets output to the pipeline and therefore becomes the return. So when the DSC local configuration manager runs test target resource, it will get a true or a false. So it's going to run test target resource. It's going to pass in the computer name, credential, possibly domain name, possibly workgroup name, one of the two. It's going to pass in the ones it wants the computer to be, and it's going to get back a true or a false if the computer complies with that. Now let's dive into the cool one, the one that actually makes it all happen. Set target resource. Again, we're passing in the name, domain name or workgroup name, and if we pass in a domain name, we should pass in a credential. So this is what we want the computer to look like, and we want it to happen. Again, this starts by calling validate domain workgroup, which will throw an error if we provided both a domain name and a workgroup name. We're retrieving the current computer name from the computer name environment variable. Now, if we provided a credential and if we provided a domain name, we're going to go get the current domain name. So one of the things that this set implementation has to do is decide if it has any work to do, and that's what this is doing. If the domain name you specified is the current domain name, in other words, if everything is always the same, then we're just going to rename the computer to its new name using our domain credential. Otherwise, if the computer name is not the same as the current name, we're going to join it to the domain. Otherwise, it's the same computer name that needs to be joined to the domain. So we're covering all the different possibilities. We're covering we need to join to the domain and we're not changing the computer name. We need to join to the domain and we are changing the computer name. We need to change the computer name and we're already in the domain. All those different possibilities are covered by the logic. If we specified a workgroup name, on the other hand, we go through essentially the same logic. New computer name, staying in the same work group. New computer name, joining to a work group, same computer name joining to a work group. Now, if the configuration did not provide a domain or a work group, then we're just looking to see if the computer name matches the current computer name, and we'll change that as needed. So there's a bunch of logic, but most of this is just dealing with all the possible situations. So the point of this is, in a set resource, you accept the configuration that the person wants. Then you have to check and see what of that is already implemented and what needs to be done, and you have to do just what needs to be done. For example, let's say this specified the Contoso domain, and the computer's already in the Contoso domain. You have to check that in the resource. You can't try to rejoin it to the domain if it's already in the domain. So your logic here has to figure out what is already in place, what isn't in place, and you have to implement only the things that aren't already in place, which means checking everything before you do it to see if it's already been done. So certainly not super uncomplicated, but fairly straightforward. And keep in mind, you can come back and look at any of these other resources here. For example, networking. Oh, and by the way, I think this is a neat thing. Stephen Murawski, who's one of the guys who kind of leads up this little open source project, he works for Stack Exchange, the people that run serverfault.com and stackoverflow.com. And a lot of these are modules that they're actually using in their production environment. They have a policy of open sourcing as much of their code as possible, and so Stephen was able to share all this. So this is stuff that actually gets used in production. That's why it's a kind of a neat thing to look at. So let's look at just another one real quick. This is the networking networking resource. And this contains two different things. This is working with DNS server addresses and IP addresses. So we can look, and I'm going to grab the script module. There it is. So again, we start off, there's the get target resource. There's set target resource, that's a really short one, and test target resource. This has also got a validate properties. Now this is a neat architectural thing. Remember, really, in your set target resource, you do have to check and see what has been implemented and what hasn't. In your test target resource, that's all you're doing is checking to see what has been implemented and what hasn't. So what they've done here is they've built a little internal module that checks to see what is implemented. And the difference between this test and the set is this here. So this internal validate properties is going to take all the configuration information, and for a set call, it applies them. For a test call, it simply doesn't apply them. That allows all the check and see what's been implemented logic to live in a single location. And as you can see, it's reasonably complicated. So rather than copying and pasting that and implementing it twice, they consolidated it into one place. And I'm going to look for the spot where it checks to see if we're asking for application. Let's see. So there's the switch for apply. That's where that gets defined. We're checking to see if it's been done or not. Oh, there it is, line 124, if apply. So if this was run, so right here, this is where we check it. Oh, it's not correct. And if you told me to apply it, then I'll fix it. Otherwise, I'm just going to return a false indicating that it is not currently applied. So that allows this logic to be consolidated into a single location. So there's no question that writing DSC resources can be a little tricky just in terms of you have to figure out how to do and how to check whatever it is you want to do and check. But the structure for the DSC resource is pretty straightforward. It's just those three special functions that have to have those names, and then the little moth schema file that indicates what properties each of those three functions will accept as parameters. So now you know where Windows keeps its native DSC resources. You also have seen how to go through and look at a custom resource so that you kind of understand some of the options you have for building one, as well as the minimum mandatory sort of signature, the structure and layout that it has. Now, writing a custom resource isn't that difficult just for that structure. What becomes difficult about writing a custom resource is writing whatever code you need to accomplish whatever task you're trying to perform. Now, hopefully, all the preceding nuggets have lined you up enough so that you kind of have enough knowledge of PowerShell that you'll be able to tackle that when you come to it. Once you can write the commands to implement or check a configuration, turning them into a DSC resource really turns out to not be all that hard. I hope this has been informative for you, and I'd like to thank you for viewing.